In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. For as long as there have been people to look up, the night sky has been an endless source of wonder and mystery. It's easy to understand why. Like so much of the natural world, the stars, planets, and other objects that fill the heavens exist in plain sight. But unlike just about anything else, they also exist beyond human reach. For our ancestors, this made the night sky a supernatural place. A place they eventually filled with mythical beasts and the gods. In time, this mythical view gave way to a more mathematical understanding of the sky. But the stars remained as mysterious and distant as ever. Unable to touch the heavens, humans eventually came up with an ingenious device to bring the heavens closer. It's called the telescope. Although telescopes today vary in size and complexity, the underlying principle is always the same. At its heart, a telescope is a device that magnifies our sight. Using mirrors or lenses, and often both, it makes distant objects appear closer. In this way, the telescope can reveal details about our universe that are inaccessible to the naked eye. Equally important, a telescope is like a funnel for light. It's wider at one end, and it grows progressively narrower as it gathers and concentrates far more light than would otherwise pass through the narrow pupil of the human eye. And this is why, through a telescope, objects that are dim appear brighter, while objects that are too faint to be seen at all emerge from the shadows. Because it extends the power of the human eye, the telescope was the tool that finally allowed astronomers to see what kind of universe we live in. As it turns out, it's a far larger and deeper universe than our ancestors ever imagined. It was only after the telescope was invented that people began to grasp that our entire world is just one planet among many. And that our sun, in turn, is just one star in a galaxy we call the Milky Way. A galaxy that holds 100 million times the number of stars that can be seen with the naked eye. Thanks to the telescope, the Milky Way was itself revealed to be just one among billions of other galaxies. Great islands of matter and light adrift in a cosmic ocean that is as vast as it is dark. But for all the power the telescope brings to the study of our universe, for nearly 400 years, it was limited by a factor beyond human control. For Earth-bound stargazers, the atmosphere is a fickle window on the cosmos. Its constantly shifting patterns mean that our exploration of the night sky is conducted at the whim of the weather. Even on the clearest night, the air above Earth is always in motion, like a turbulent cauldron of invisible soup. This ever-changing turbulence bends and distorts the incoming light of stars and galaxies. Even for the biggest and best telescopes in the world, the fine details of our universe are blurred away. If the effects of Earth's atmosphere could somehow be eliminated, we would improve our view of the universe 100-fold. It would be the biggest single leap forward since the invention of the telescope. Took that leap. The Hubble Space Telescope was lofted into orbit aboard the Space Shuttle Discovery.
Lots of clearance. Come in starboard nicely. A little bit more.
Okay, let's do it.
Okay.
Years in the making, the telescope was named in honor of Edwin Hubble, the celebrated American astronomer who first proved that galaxies exist and demonstrated that our universe is expanding.
Okay, we have a go for release. Okay, Charlie.
With its unique status as the first large telescope to operate outside the limits imposed by the atmosphere, astronomers hoped that Hubble's namesake would lead them to equally important discoveries.
Houston Discovery.
Go ahead, Charlie.
Okay, Story. We've been taking marks. Residuals and ratios look good, and we'd like to go ahead and go to filter state.
Expectations were running high, but what astronomers saw was not what they expected. Within days of Hubble's launch, it became obvious that the telescope could not see properly. Images that should have been crisp and detailed were blurry. The problem was soon identified. A slight but fatal flaw in Hubble's main mirror meant that it was unable to focus incoming light. The flaw had been introduced years before due to an error in the way the mirror was tested during its manufacture. It had gone unnoticed until the Hubble was already in orbit. Fortunately, the Hubble's disastrous debut came with a silver lining. Because the flaw in its mirror was so well understood, it was possible to craft a precise set of corrective optics. It was the astronomical equivalent of contact lenses. The result was spectacular. After its dramatic repair in December of 1993, the out-of-focus images that Hubble had been beaming down to Earth were replaced with views of breathtaking clarity. The pictures were not only better, they were the best astronomical images in history. For the first time since the invention of the telescope, astronomers had a new way of seeing the sky. One that would change our view of the universe forever and fill our eyes with images of breathtaking beauty. The age of Hubble was underway. Sometimes the power of great art is the way it reveals the extraordinary within the ordinary. In the universe, there's nothing more ordinary than the death of an average star. But when seen through the Hubble Space Telescope, this unexceptional event becomes a scene of stirring beauty and rebirth. When a typical star runs out of energy, it cools and expands. Like a dying gasp, its outer layers are puffed outward into space, forming an expanding bubble of glowing gas. As the bubble grows more diffuse, the star's core is soon laid bare. It is now a tiny but intensely hot white dwarf star. The intense radiation it gives off energizes the expanding gas, which takes on the appearance of a luminous flower blossoming in space. It's called a planetary nebula because over a century ago, astronomers thought that the rounded shapes of objects like this looked like distant planets. For the Hubble, a planetary nebula offers more than an opportunity to study the final stages of a star's life. Each one of these colorful blossoms is unique, like a flower in a painter's still life. Among all the objects in the universe, they have added some of the most beautiful and breathtaking images to Hubble's collection. And they are as diverse as they are beautiful. While some are symmetrical and round, others have turbulent and complex structures. Here, Hubble zooms in on one of the best examples. This planetary nebula resembles a bow tie. Its complexity tells us that the nebula likely formed in a series of ejections, rather than one great outburst. This is also true of the Cat's Eye Nebula. Astronomers are still trying to decipher the events that formed this unusual object. Near the center lies a series of intersecting shells that were ejected from the dying star over the past 1,000 years. Two jets of material have pierced these shells on opposite sides. Meanwhile, these structures sit within a larger succession of concentric shells, which were released over thousands of years in regular bursts and which now make up the outer portions of the Cat's Eye. One theory that may help explain the unusual shape of the Cat's Eye holds that the nebula's central star is not a single white dwarf star, but two stars in a close orbit around each other. The idea that the presence of a second star can greatly complicate the shape of a planetary nebula is already known from another striking example. Astronomers call this object the red rectangle. Here, it's believed that two stars are in orbit around each other, with a ring of dust surrounding both stars. When one star aged and began ejecting its outer layers into space, the ring became a waistband, forcing the material to move outward in two narrow cones rather than in a spherical shell. The Hubble can also show us many other examples of a planetary nebula with an hourglass shape. The cause of this shape may not be the same in all cases. Different theories suggest that the gravity of a companion star, large planets, or simply the interaction of gas with a star's magnetic field can explain their remarkable forms. Now, with Hubble's penetrating eye, astronomers are zeroing in on some of the largest and brightest examples, searching for clues to their formation and structure. They have good reason to be curious. A planetary nebula may be lovely to look at, but its true significance to us lies in the nature of the material it releases into space. The vivid color in this Hubble image corresponds to different atoms emitted by the dying star. In this case, the green light represents oxygen atoms, while the red color is due to nitrogen. The shells of stellar debris expelled by dying stars are not simply made of atoms, the basic building blocks of matter. They also produce molecules, combinations of two or more atoms, including molecules that are instrumental to the origin and development of life. In the past, it was believed that such molecules would be destroyed by the intense radiation from the white dwarf at the center of each planetary nebula. With Hubble's help, astronomers have learned this is not the case. Among the best locations to study this exciting new development is the Helix Nebula. It is one of the nearest examples of a planetary nebula to Earth, which makes it an ideal target for the Hubble. The catch is that the Helix Nebula is large, much larger than the Hubble's field of view. To capture the entire nebula, Hubble took many separate images, which were combined to make a grand mosaic. Normally, there would not be enough room in Hubble's schedule to dedicate so much time to a single object. But a few years ago, a passing cloud of meteoroids forced the telescope to be placed in a protective mode. In order to shield its vulnerable primary mirror, Hubble kept its back to the incoming meteoroids, and as a result, had to stare at the same part of the sky for many hours. Fortunately, that part of the sky included the Helix Nebula. So what has Hubble found in this incredibly detailed view? Like other examples, we find the Helix Nebula is composed of nested structures, one inside the other, each blown off in different episodes during the central star's transition to a white dwarf. But because the helix is so much nearer than other examples, astronomers can see much more detail within those structures, and they have a better chance to explain how they formed. One result of this investigation is that it's now clear the helix contains a pair of gaseous disks that are tilted with respect to each other. This reconstruction shows what the Helix Nebula might look like if viewed from another angle. At this angle, the two disks are more obvious. But exactly why they are oriented in this way is not so easy to understand. Perhaps, as in so many cases, it's because the star at the center of the helix is really two stars in one, which has complicated the structure of the expanding nebula. Even more intriguing than the helix's overall shape are the many tiny clumps of material that show up on the inner edge of the nebula's glowing rings. Astronomers have dubbed these objects cometary knots because they look so much like comets with their long streaming tails. These knots cannot be comets, however, because they are too large. Instead, it's believed they are denser clumps of material that formed within the expanding shell of the Helix Nebula. As the fast-moving stellar wind from the central star pushes outward on the nebula, the clumps are gradually exposed. But while the bright gas in much of the nebula is seared by the incredible heat of the central star, the molecules within the cometary knots remain protected. Here, carbon-bearing molecules can form and survive until they are eventually dispersed into interstellar space. This is why places like the Helix Nebula are cosmic flowers in more ways than one. After they blossom, they not only dazzle us with their fleeting beauty, as Hubble has shown, they are also scattering the seeds of future life. In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. In the beginning, there was light. So much light that when the universe formed, every corner of space blazed white hot. But it didn't last. As the infant universe expanded, it cooled, and its light faded. For 200 million years, darkness reigned. And then, light was reborn. It was gravity that gave the universe its new look. Gravity drew matter together into vast swirling clouds. While deep inside the clouds, dense concentrations of matter coalesced and began to glow. As these concentrations grew, the pressure and heat at their cores became enormous. Until, with a flash, nuclear reactions ignited. Suddenly, a new kind of light was shining in the universe. The light of countless newborn stars. When you think of the elements that make up a painting, you might think of color, form, subject, but you probably don't think about the light that lets you see the painting in the first place. In space, it's just the opposite. There, light is the subject, especially the light from stars. In fact, it's the way starlight interacts with the matter around it that makes the universe so revealing to astronomers. The Hubble Space Telescope reminds us that in a universe painted by starlight, beauty and science often come hand in hand. Like no other instrument, the Hubble is built to explore the finest details in the light that it gathers from the stars. Where does starlight come from? In the core of each star is a natural nuclear power plant that turns hydrogen, the most abundant element, into helium. This reaction releases energy, much of which works its way through the star's interior until it's released as light. Once starlight is traveling freely through space, it can illuminate the star's surroundings, which may absorb, reflect, and re-emit the light in countless ways. This includes lighting up any gas left over from the star's formation. Normally, this interstellar gas would be transparent, but when it's energized by nearby stars, it becomes ionized and emits light of various colors. Here on Earth, the same principle lights up a city street at night with colorful neon signs. Gas may add color to Hubble's canvas, but it's dust that creates some of the most striking views in space. The dust comes in the form of microscopic grains, no bigger than particles of smoke. But when trillions of them get together, they block and absorb light. Our galaxy is full of dust, and when there's a cloud of glowing gas in the background, the dust stands out in dramatic silhouette. One of the best-known examples of this effect is the celebrated Horsehead Nebula. From a distance, it appears like a horse-shaped hole carved out of the surrounding gas. But looking more closely, Hubble reveals the Horsehead Nebula as never before. A towering pinnacle of dark dust so vast, it would take a beam of light 2 years to cross from the tip of its nose to its mane. Such dark clouds are often found in regions where new stars are forming. They are full of elements like carbon and silicon that are essential for creating solid rocky planets like Earth. Once, the rocks and dirt that make up the ground beneath our feet began as tiny grains of dust swept into a dark cloud like this one. If all dust did was block light, it would still make the universe a more beautiful place to look at. But dust can also do something even more interesting. It can scatter light. To witness this remarkable spectacle, the Hubble cast its gaze across our home galaxy, the Milky Way, to a star so brilliant and so distant, its light takes 20,000 years to reach us. Normally, such a star would appear as nothing more than a faint speck of light. But this star is a giant, one of the brightest in our galaxy. It is also on the verge of running out of energy. And like a dying flame, it surrounded itself in a smoky cloak of dust. In early 2002, the star brightened suddenly and then faded. As Hubble watched, the brilliant flash produced what astronomers call a light echo. Month after month, Hubble recorded the initial flash of light from the star as it scattered and reflected off the surrounding dust. Viewed in sequence, the result creates the illusion of a cosmic flower in bloom. Closer to home, this sequence of Hubble views of the planet Mars shows the dramatic effect of scattered light. Normally, the surface features of Mars make for an easy target with the Hubble, until a planet-wide storm wraps Mars in a cloak of fine airborne dust. The Pleiades, a nearby cluster of stars also known as the Seven Sisters, plows into a cloud of dust while on its trek through the galaxy. In this image, taken by a ground-based telescope, you can see the dust scattering the light of the cluster's young blue stars. Moving in for a much closer look, astronomers have used the Hubble to explore the dust in fine detail. The telescope has revealed wind-swept features that are caused by the force of the star's bright light pushing the dust back. The idea that light can move matter may seem surprising, but it comes straight from the most fundamental laws of nature. Light carries energy, and when light is absorbed by fine particles of dust, the energy makes the dust recoil in response. When this simple effect plays out on the grand scale, it means that starlight isn't just the painter of our universe, it's the sculptor as well. Nowhere is the sculpting power of starlight more apparent than in the fabulous Eagle Nebula. This dramatic Hubble close-up shows part of a dark column of dust silhouetted against a background of glowing gas. Stars are forming before our eyes in this delicate dusty pillar, even as it is shaped and eroded by the intense light from other stars within the nebula. Hubble's unprecedented view of the Eagle Nebula offers vivid proof of the powerful force that light can exert. Like a desert wind that builds and shifts mighty sand dunes, here, light is the invisible hand that guides both the creation and destruction of pattern and complexity in space. Everywhere we look in the universe, our view is determined by a graceful intertwining of matter and light. When viewed at the scale of an entire galaxy, the glowing clouds of gas that are lit up by the energy of newborn stars stand out like snow-capped mountains, while the tendrils of dust that thread their way between the star-forming regions look like networks of lakes and rivers. Pulling back, Hubble shows us how these patterns of light and dark shape our impressions of what galaxies look like, and provide key insights into our understanding of the forces that create their appearance. With Hubble, we can see that we live in a universe not only painted by light, but one where masterpieces abound, and where a powerful telescope can reveal the hidden beauty in every faint patch of light glowing far off in the night sky. An accomplished artist does not spring into being fully formed. It can take years of practice and exploration before a creative talent matures and is ready to tackle big subjects on a big canvas. So too with the Hubble Space Telescope, which has been in orbit around Earth and capturing images of the heavens for nearly 2 decades. Yet, despite a long and colorful career, it is arguably only now that the Hubble is producing its greatest masterpieces. One reason for this is that the Hubble was originally designed to provide the sharpest, most penetrating view of the universe possible. But this means it cannot see more than a small portion of the sky at any one time. A single frame of Hubble's most advanced camera would cover less than 1/10 the diameter of the full moon. And that means some of the most interesting objects in the universe are much too large to fit in Hubble's field of view. When Hubble was launched, astronomers had a long list of things they wanted to see. Now that Hubble's seen them, astronomers have the luxury of being more creative. That means using the Hubble to capture images that are both wonderfully sharp and breathtakingly large. In principle, it's easy to do. It just takes time. With time, you can point the telescope over and over at adjacent portions of the sky. This leaves you with dozens of separate images. But when assembled like a mosaic, they become one giant picture. When you're trying to take in something as vast as the universe itself, it's an approach that can't be beat. That's precisely what astronomers decided to do when they wanted to get a sense of what the entire universe was like when it was less than half the age it is now. First, they chose a relatively empty corner of the sky that was largely free of stars and nearby galaxies. The best place to do this turned out to be just off the corner of the Big Dipper, one of the most recognized star patterns in the night sky. Compared to the Big Dipper, the area astronomers examined is small, a narrow strip that can easily be covered up with an outstretched finger held up against the sky. But to capture even this small a slice of the universe, Hubble had to take more than 500 separate images using a variety of different filters. Ultimately, all of this information was assembled into one giant mural, a cosmic group photo that includes at least 50,000 individual galaxies. To let your gaze wander across the single strip of the night sky is to experience our universe in all its vastness and variety. Only Hubble could create a view like this one, a view that opens up more of deep space to the human eye than any other image in history. Looking more closely, Hubble has found that this random sampling of galaxies contains surprising diversity. Some of the galaxies are spiral-shaped, like our own home galaxy, the Milky Way. Yet others appear jumbled and distorted. These galaxies are still under construction. Because they are so far away, their light has taken billions of years to reach us. Hubble sees them not as they are now, but as they were billions of years ago when the universe was just emerging from its tumultuous beginnings. Much closer to home, Hubble's ability to build a mosaic out of many smaller frames means that we can witness the assembly of an entire galaxy on our cosmic doorstep. This galaxy is smaller than the Milky Way, but it's relatively close. Instead of taking billions of years, its light takes a mere 12 million years to arrive here, so it makes an ideal subject for the study of galaxy formation. Like its more distant counterparts, the galaxy is not a graceful spiral, but a bright and chaotic jumble of stars. Its irregular appearance is the result of a collision between smaller galaxies that gravity has pulled together to make a larger system. This forced collision has triggered a dazzling burst of star formation. Here we see thousands of young stars, along with splashes of diffuse pink light, the glowing clouds of hydrogen gas where new stars are being born before our eyes. From the universe at large to a single galaxy, Hubble has revealed beauty and insight at many levels and over great distances. But perhaps its greatest masterpiece comes from its exploration of the nearest star-forming region to Earth. The light from the Orion Nebula takes just 1,500 years to reach us. It's even faintly visible to the naked eye as part of the constellation Orion the Hunter. A pair of binoculars is enough to reveal that it's not an ordinary star, but instead looks more like a small patch of mist in the sky. Around the world, telescopes for years have revealed that patch of mist as an impressive nebula where new stars are being born. But until now, no telescope has been able to show us the Orion Nebula at this level of detail. More than 500 Hubble images were used to create this exquisite mosaic. Through Hubble's eye, the nebula is revealed as a vast, billowing field of gas. Its structure is like an oyster shell, opening toward us. At the center is the trapezium, a cluster of 4 intensely bright giant stars, 100,000 times more luminous than our own sun. These stars produce enough ultraviolet radiation to energize the surrounding hydrogen and light up the inner portion of the nebula like a flame inside a lantern. These stars also generate powerful winds of high-speed particles, which are pushing at the gas and gradually driving it away from the center. With the Hubble, astronomers can now study every wrinkle and fold in the nebula's complex structure to better understand this process. To gain even further insight, the Hubble image has been combined with an infrared view from the Spitzer Space Telescope. It shows more activity and structure in regions where the gas is too cool to glow in the part of the spectrum visible to the naked eye. The colors that add so much beauty to the image are also the key to understanding the chemical composition of the nebula. Wisps of green light are partly due to atoms of sulfur, while some of the red light around the outskirts of the nebula is produced by chemical compounds that are rich in carbon. And there is more. In one of its most celebrated discoveries, the Hubble has confirmed that the Orion Nebula represents a new generation and a new beginning for thousands of stars. When Hubble searches among the nebula's feathery filaments, it finds ample evidence that new solar systems are being created here, much the way our own solar system came into being billions of years ago. Looking at this magnificent image, just one among so many great views from the Hubble, we come, in the end, to a deeper realization. It's not simply abstract beauty that draws us to this masterpiece, but a feeling that within its glowing wonder is an underlying truth that tells us something about where we came from, a truth that connects us directly to the universe we observe. In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. Color is one of the artist's essential tools. In a painting, color draws the eye and plays on our emotions. Its effects can be subtle or dramatic. In astronomy, color serves a different purpose. When measured precisely, it can tell us about the temperature, chemical composition, and motion of astronomical objects. In this way, color can transform a static picture of the night sky into a detailed portrait of a dynamic and evolving universe. Like a great artist, the Hubble Space Telescope has become a master of color. In the process, it has changed the way we see the universe. Color is so important to the images Hubble provides, it may come as a surprise to learn that the Hubble's cameras are essentially black and white. To create the vivid colors we see, Hubble has to image the universe through a variety of filters. Astronomers then decide how to combine those filters, often to astonishing effect. Here's how it works. Each time the Hubble looks at an object through a different filter, it produces a black and white image that corresponds to a particular wavelength of light. The black and white images can then be assigned colors, like red, green, and blue. When 3 or more of these images are combined, the resulting full color image can accentuate important scientific details. Here, ruby red and emerald green allow astronomers to dissect the complex history behind the Cat's Eye Nebula, a cloud of debris ejected in stages from a dying star. And by using color in different ways, Hubble not only gains new information, it reveals a natural wonder of staggering beauty. Depending on which filters are chosen, Hubble can recreate the way an object would appear to the human eye, like this view of the planet Saturn, with its cream-colored cloud tops and its icy white rings. But here, Hubble shows us Saturn as we've never seen it before, with different colors representing the light that comes from different layers in Saturn's atmosphere. In this case, Hubble's strategic use of color has turned a flat picture into a three-dimensional voyage to another world. One kind of information that color can reveal is temperature. In this young star cluster, all the stars formed together, and so they are all the same age. But some stars have exhausted their fuel so quickly, they have already expanded and cooled. The red light they give off indicates a lower temperature. Meanwhile, the hottest stars in the cluster shine a radiant blue. Like an exploding rainbow, Hubble's view of the bizarre Egg Nebula reveals what no other telescope can. At the center of the nebula, an aging star is repeatedly expelling material into space. The material forms a series of dusty shells, nested one inside the other. Hubble can view the shells as though through a pair of polarized sunglasses, with different colors representing light that has been reflected and aligned in different directions by the dust. The results provide astronomers with a detailed picture of how the dust is distributed. Hubble's powers of perception extend beyond the spectrum of colors that our eyes can see. Here, the telescope uses ultraviolet light to witness the unfolding of a spectacular display of aurora flickering around Saturn's south pole. Without Hubble, we would never see views like this. As much as Hubble can reveal on its own, it can reveal even more when it works in concert with other instruments that view the universe at drastically different wavelengths. Together with the Chandra X-ray Observatory and the Spitzer Space Telescope, which sees deep into the infrared, Hubble leads a fleet of orbiting explorers, which has opened our eyes to the full spectrum of information arriving from deep space. For example, these ragged patches of glowing gas seem to be all that remain from a supernova that was recorded by the astronomer Johannes Kepler in 1604. The brightest areas mark the crest of a powerful shock wave that's moving outward from the site of the explosion. But now, Hubble's view is combined with data from the Chandra X-ray Observatory and the infrared-sensitive Spitzer Space Telescope. It's clear that there is much more to the explosion's aftermath than meets the eye. The X-rays show the hot gas in the wake of the shock wave, while the infrared shows a warm glow from dust particles that were heated by the supernova. This kind of composite view is incredibly useful for astronomers because it contains multiple layers of information. Here, it helps us to understand how new atoms are forged in the fiery furnace of a supernova explosion. Atoms that could someday become part of future solar systems and even new forms of life. On a much larger scale, Hubble can also team up with other instruments to discern powerful forces at work in remote corners of the universe. The light from this cluster of galaxies takes more than 2.5 billion years to reach Earth. As seen by the Hubble alone, these galaxies look timeless and serene. When Chandra looks at the same cluster, it finds that the galaxies are embedded in a cloud of high-temperature gas that's emitting X-rays. And there is a further mystery. The gas cloud contains 2 hollow cavities on either side of the cluster's bright center. Finally, a third view, created with ground-based radio telescopes, reveals the answer. It shows 2 jets of high-speed particles that have been ejected from the cluster's largest and brightest galaxy. The particles are moving at nearly the speed of light, pushing aside the hot gas and carving out the two cavities. The energies involved here are unimaginable and could only have been unleashed by a giant black hole. This lurking beast is too far away for even Hubble to observe directly. But the power of Hubble, combined with other instruments, has allowed us to understand the awesome forces at work in this faraway cluster of galaxies. It's not just the universe's most extreme and violent places that are best explored with a combination of telescopes spanning the full spectrum of light. This is one of the crown jewels of the night sky. Nicknamed the Sombrero Galaxy, it is too near and too large to fit into one Hubble telescope image. Instead, this portrait is a mosaic made of 6 separate Hubble images. The sombrero gets its name from the dark brim of dust that hides the regions where new stars are being born. But by adding infrared data from the Spitzer Space Telescope, the dark dust is transformed into a glowing red ring. This incredible view drastically improves the clarity with which we can see into the interior of the galaxy. Everywhere that Hubble sees color, it has the potential to reveal new information about the universe. In this sweeping view, Hubble clearly finds that some galaxies are more red than others. This has nothing to do with temperature or with chemical composition. Instead, it's the expansion of the universe itself that makes the light from extremely distant objects in space appear red. Astronomers call it the redshift. Discovered nearly a century ago, the redshift is our key to measuring how far away galaxies are and how fast the universe is expanding. With Hubble, astronomers have made these measurements with unprecedented accuracy. In space, as in art, color tells a story. With the Hubble, astronomers have a storyteller like no other. Like great art, the Hubble Space Telescope can capture the things that touch us most deeply, from birth to death to epic battles. The difference, of course, is that with Hubble, the battles play out on a galactic scale, and the result is always a feast for the eyes. Two nearby galaxies adrift against the endless void of space, each one a sprawling city of stars. Like ships in the night, they seem to be passing by one another, but such encounters are not without consequence. The larger of the two galaxies is a majestic spiral, similar in size and appearance to our own galaxy, the Milky Way. It contains hundreds of billions of stars and enough matter to wreak havoc on its smaller neighbor. That neighbor is just a short hop away by cosmic standards. But it's curiously different from the first galaxy. A ground-based telescope can show both galaxies in the same field of view. But it takes Hubble to zoom in on the smaller object, revealing an incredible sight. For here is a galaxy that seems to be exploding before our very eyes. Triggered by the gravitational pull of the larger galaxy next door, dormant clouds of hydrogen gas in the smaller galaxy are collapsing to produce new stars at an astounding rate. In its central regions, the entire galaxy seems to be on fire with the energy of thousands of newborn suns. With a clearer view than any other telescope, Hubble reveals the streamers of hydrogen gas flowing outward from the galaxy's center as they are carried on winds of high-energy particles. To complete the picture of this exotic galaxy, astronomers take the Hubble image and add information that Hubble alone cannot see, including infrared and X-ray emissions. When viewed collectively, we are witness to a scene of power and violence far beyond all human experience, a cosmic inferno that staggers the imagination. We do not have to look far to find energy and chaos in the universe. We can even find it in the spiral arms of our own Milky Way galaxy by peering into places like the Eta Carina Nebula, a colorful jewel of the southern sky. Seen through Hubble's penetrating eye, this magnificent formation appears as a great expanse of turbulent gas, where new stars have been under construction for the past 3 million years. The brightest of these stars illuminate the nebula with their intense radiation and push at the gas and dust to create a cloudscape that gives the impression of a storm-tossed sea. Wherever Hubble looks in the Carina Nebula, the interaction between matter and energy creates vivid forms that speak to us about the genesis of stars. In some places, radiation eats away at the dustier portions of the star-forming cloud, creating long peninsulas of dense material that resist the erosion. In some cases, the peninsulas have turned into free-floating islands that are the cocoons of new stars and new solar systems. But amid these new beginnings are the hints that violent endings will soon follow. With so much material available for star formation, some of the stars that are created in the Eta Carina Nebula quickly become overgrown beasts containing 50 to 100 times the mass of our own sun. About a dozen such monsters exist today inside the nebula, none larger than Eta Carina itself. In the 1840s, astronomers saw this star flare up to become one of the brightest stars in the night sky. Now, over a century and a half later, Hubble has become the first telescope to show us exactly why. Although Eta Carina is a brand new star in celestial terms, a few million years old at the most, it is already starting to blow itself apart. Zooming in for a closer look, Hubble detects two giant lobes of material exploding outward like twin mushroom clouds. It was the ejection of these clouds that caused the most recent brightening of Eta Carinae, and it is likely just the prelude to a far more spectacular death when Eta Carinae ends its life by going supernova. A supernova is among the rarest and most spectacular sights in the universe, and one upon which our very existence depends. When a massive star tears itself apart, it can unleash the energy required to create new atoms. Here on Earth, every ounce of gold in a pharaoh's tomb, every speck of uranium in a nuclear reactor, every inch of copper in every electrical wire on the planet came into being in the furnace of some long-forgotten supernova. In the aftermath of this cataclysmic finale, these precious atoms are scattered far and wide, eventually to become the building blocks of new stars and planets. By observing the nearest examples of past supernova explosions, Hubble is helping to probe the nature and distribution of matter in space and track the way atoms forged in the death of one star are eventually cast out into the galaxy to become the seeds of new solar systems. Less than 400 years ago, the last supernova to rattle our corner of the Milky Way erupted in the direction of the constellation Cassiopeia. Because the supernova was hidden behind dense clouds of dust, the event was not noticed by astronomers of the time. Centuries later, Hubble provides our best view ever of the expanding shell of debris from this explosive grand finale. It is an enormous structure, more than 15,000 times the diameter of our solar system, and still growing. For sheer beauty, nothing can match this dazzling Hubble close-up of the Crab Nebula, the beautiful remnant of a supernova that exploded nearly 1,000 years ago. Delicate tendrils of matter from the explosion reach outward into the surrounding space. These are the visible signs of the rich cosmic chemistry at work inside the nebula, which is full of atoms that are key to creating new worlds and new life. Looking deeper, Hubble also allows us to glimpse a much more exotic form of matter. Here, at the center of the Crab Nebula, we find evidence of the collapsed core of the star that went supernova long ago. More massive than our Sun, this bizarre object is now much smaller than Earth. Astronomers call it a neutron star, an object so dense its very atoms have been crushed out of existence. This time-lapse view reveals the concentric rings of material swirling around the neutron star, which itself is spinning at the frantic rate of 38 times per second. This is what happens to matter when the laws of physics are pushed to their limits. Thanks to Hubble, the Crab Nebula, and other spectacular explosions that mark the deaths of the brightest stars can be captured and studied like great works of art. These violent endings are our chance to see nature at its most extreme, and they lead us into unknown territory where scientific theories of matter, energy, space, and time are challenged. This is ultimately why Hubble is so important, and so much like an artist loose among the stars. It doesn't just change the way we see the universe, it changes the way we think about it. In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. For most of human history, the night sky was something you looked at. A jewel-studded canopy that stretched from horizon to horizon. To our ancestors, this perspective offered no hint of the universe's true depth. Wherever they looked, the stars seemed equally remote, like glowing dots painted on a distant ceiling. After the invention of the telescope, humanity experienced a shift in cosmic perspective. The shift was gradual, but it was profound. The more the telescope revealed, the more obvious it became that the universe has a third dimension. Now we understand that when we're looking at the sky, we're really looking into space. The Hubble Space Telescope is ideal for plumbing the depths of the universe's third dimension. From its lofty perch high above Earth's atmosphere, it can see both nearby and distant objects with unwavering clarity. Its many spectacular images form a visual pathway that leads us from the boundaries of our own planet to the most distant corners of the cosmos. That pathway begins with one small step to a rocky satellite that is large enough to be considered Earth's sister world. Compared to our lush and watery home, the dry, barren moon hardly seems like a close relative. But the differences are deceiving. The Earth and Moon share a common origin. By exploring the Moon's ancient surface, scientists can uncover secrets about our own planet's remote past. The Moon also functions as a giant mirror that reflects sunlight in our direction. Because Hubble's sensitive optics would be damaged by looking at the sun directly, astronomers have pointed Hubble toward the moon to measure the colors in the sun's reflected light. At the same time, they opened up Hubble's cameras for a close-up view of our nearest neighbor in space. Because the Moon and Hubble are moving so quickly relative to each other, the Moon is one of the most difficult targets for the Space Telescope to capture. A short leap from the Moon takes us further into the inner solar system for a false color look at the atmosphere of Venus. Venus is a planetary inferno, where a surface that is hot enough to melt lead is cloaked in dense clouds of sulfuric acid. In contrast, Mars is a rust-colored desert, where liquid water may still trickle beneath the surface, and where someday the past traces of microscopic alien life may yet be found. Past the orbit of Mars lies the outer solar system, the realm of the gas giant planets, beginning with Jupiter, the largest of them all. Jupiter is not a solid world, but a vast globe of liquid hydrogen and helium, more than 300 times the size of Earth. With astounding clarity, Hubble offers us an ever-changing view of Jupiter's swirling, multicolored atmosphere. Now, Hubble carries us to the frozen fringe of our solar system, home to the dwarf planet Pluto and its large moon, Charon. Pluto is so far away, it has yet to be visited by a planetary probe. But in 2005, astronomers using the Hubble discovered that Pluto also has two smaller moons, now called Nix and Hydra. This discovery was used to construct an artist's impression of what it might be like to stand on Pluto's surface, where hills tinged by nitrogen frost are illuminated by the light of 3 moons. At such extreme distances from the Sun, there is very little light available to reveal what lies after Pluto. But Hubble's penetrating eye has revealed an entire population of tiny worlds lurking in an endless night. This is Hubble's best glimpse of Eris, an icy world that is larger than Pluto, but more than twice as distant. If we could look homeward from Eris, we would find that Earth is already too faint to see, and the Sun is merely the brightest star among many others. Now the true expanse of our 3-dimensional universe begins to sink in. As we journey deeper, crossing the great ocean of interstellar space, we discover that our solar system is part of something 1 million times larger. A great starry metropolis called the Milky Way galaxy. With stars numbering in the hundreds of billions, our galaxy includes nearly everything our ancient ancestors could see in the night sky, and much, much more. Compared to our Sun, some of the stars we find in the Milky Way are luminous giants, nested in thick clouds of gas and dust where they only recently formed. In one such cloud, so far away its light would take 8,000 years to reach us, we find what appears to be one of the largest stars in the galaxy. That is, until the Hubble discovered it is really two stars in one, each more than 100 times the mass of our Sun. At the other extreme, Hubble spies a red dwarf star, so small and dim it will shine for 1 trillion years, throwing its crimson light onto an even smaller companion. This smaller object is believed to be a brown dwarf, a tiny ball of gas that is halfway between being a planet and a star. Brown dwarfs were first hypothesized years ago when they were too faint to be seen from Earth. Among Hubble's most important achievements is the confirmation that brown dwarfs exist in great numbers throughout our galaxy. Some stars are not solitary, but are congregated into giant globular clusters. Like a swarm of glowing fireflies, the star cluster known as M80 captures Hubble's roving eye. It was by carefully measuring the distances and distribution of globular clusters like this that astronomers first discovered the true dimensions of our Milky Way. We now know it is a great spiral system, a whirling disk of stars, gas, and dust so huge it takes light 100,000 years to cross it. But just as the solar system was our stepping stone to a much larger reality, so in turn, the entire Milky Way gives way to the unimaginably vast universe that lies beyond. This is the universe our ancestors, with their two-dimensional perspective of the night sky, could not perceive. A universe populated by galaxies in the tens of billions, as magnificent as they are diverse. It is when Hubble looks out at these faraway galaxies that we begin to appreciate the true scale of our cosmic perspective. For in the background, behind each great galaxy, Hubble reveals not emptiness, but an endless corridor showing more and more galaxies stretching back to the limits of our perception. Today, astronomers estimate that Hubble can peer more than 13 billion light-years into the cosmos. In such a large volume of space, the possibilities for discovery are staggering. Hubble has not taken us to the end point of our cosmic perspective, but rather to the beginning of a new era of exploration, an era in which the deeper we look, the more we see. The domain of the telescope is the domain of space. And in a universe like ours, there's plenty of space to go around. Because it can look so deeply into space, the Hubble Space Telescope also brings an added dimension to our view of the cosmos: the dimension of time. The light that reaches us from the far corners of the universe takes millions, even billions of years to cross the great expanse of intergalactic space. That means the light we see today departed from its source long ago in the ancient past. We can never see the universe the way it is, only the way it was. Over short distances, this effect is slight. Objects in our solar system are so near that their light reaches us with a delay of only minutes or hours. At such close range, Hubble can easily track dynamic changes as they occur. Here it captures a comet in the act of breaking up. Comets spend most of their time at the frigid outskirts of our solar system. As they dash past the sun, the change in temperature puts the comet's icy nucleus under extreme stress. In this case, the result is total disintegration. In 1992, comet Shoemaker-Levy 9 went through a similar breakup after making a close pass of the planet Jupiter. 2 years later, the train of comet fragments circled back, one by one plowing into Jupiter's atmosphere in a series of spectacular collisions. In this ultraviolet view of Jupiter, taken during the week of the collision, the vivid swirling features of Jupiter's atmosphere are muted. Much more obvious is this small dark spot, which is actually the shadow cast by Io, a moon in orbit around Jupiter. But across the planet's southern hemisphere, Hubble shows a line of dark patches formed as the fragments of comet Shoemaker-Levy 9 collided with the rotating planet one after another. The patches are dark because the dust that the collisions deposited in Jupiter's upper atmosphere absorbs ultraviolet light. In the days and weeks that followed, the dust became a marker that allowed scientists to track the winds in Jupiter's stratosphere. Beyond our solar system, we no longer see the universe in the here and now. Many of the stars and glowing clouds of gas revealed by Hubble are thousands of light years away from us, which means we see them as they were thousands of years in the past. But even at these distances, there is ample evidence of dynamic change through time. This awe-inspiring Hubble image is the best picture ever taken of the Cone Nebula. It is a cold, dark pillar of hydrogen gas and dust with a glowing top. The glow is caused by ultraviolet light from a brilliant star located just above the edge of the Hubble picture. The light is steadily pushing on the top of the cloud, creating a shadow effect underneath. In time, this pillar will be eaten away by the light, possibly revealing a nest of newborn stars. Because we are seeing this nebula as it appeared in the past, it has already gone through many changes that we have yet to witness. These changes are advancing on the scale of thousands of years, too slowly for Hubble to track. But Hubble can travel in time in a different way, by looking at clusters of young stars that formed millions of years ago out of clouds of dust and gas similar to the Cone Nebula. Looking across larger stretches of space, Hubble's canvas also encompasses longer epochs of time. Here, two galaxies careen past each other in a near collision. The smaller of the pair is the size of our own Milky Way galaxy. As it swings by its larger neighbor, gravity distorts the small galaxy, stretching out one of its spiral arms. With this pair of galaxies, nicknamed the Mice, a collision in progress has flung two long tails of stars far outside the galaxies where they were born. The Mice are now moving apart after a close encounter 160 million years ago. Eventually, gravity will halt their separation and they will fall back together into a grand merger of all their stars. In another region of space, we can see the same story carried forward to the next stage. These are the antenna galaxies, now 900 million years into a spectacular collision and more than halfway to a total merger. Here, Hubble offers us the best view yet of the heart of this astounding interaction. While the stars of the antenna galaxies are free to fly past each other at high speed, we find that something different has happened to all the dust and gas the galaxies carry with them. Gravity has pulled on this material, and now we see it spilling out into the space between the two galaxies, where it's ushered in a baby boom of star formation. Hubble's view shows a glowing network of bright pink nebulosity. It's the telltale color of glowing hydrogen gas. It highlights the nurseries where new stars are being born. In their midst, we also see brand new star clusters full of hot blue stars that have recently ignited. But while these dramatic views show us time unfolding in the universe around us, they portray a universe that is fundamentally identical to the here and now. Even though Hubble is peering into the past when it captures the light from these bright galaxies, it's only probing the recent history of our universe. But glimmering in the background, we can find hints of a deeper time when the universe looked very different than it does now. In the constellation Draco the Dragon, Hubble comes across a gorgeous spiral galaxy. Its light took 80 million years to reach us, and it looks very much like the Milky Way, the galaxy we call home. But more than 10 times farther away, Hubble also spots a quasar. This object is part of a galaxy too, one that's too faint to show up in this picture, except for its center, which is shining far brighter than any normal galaxy would appear at such an extreme distance. Quasars are inhabitants of an earlier period in the universe's history, when giant black holes at the centers of young galaxies powered brilliant eruptions of energy. Here, Hubble operates as a time machine, allowing us to witness a long vanished age. The same strategy has been used to capture Hubble's deepest view of the universe to date. It was created by pointing the Hubble at an empty patch of sky again and again over a 5-month period. At first, there was nothing to see here at all. No stars within our Milky Way, no bright galaxies beyond the Milky Way's borders. But gradually, an image began to emerge. The image of thousands of galaxies at the very limits of our cosmic horizon, going back more than 10 billion years into the past. Like a living fossil, the image reveals what the universe looked like shortly after the Big Bang, when star formation began and galaxies were brand new. As we explore these far-off islands of light, distant from us in space and time, it's clear that the galaxies of this era are not the stately spirals and other forms that are familiar to us today. These galaxies are smaller, dustier, and more disturbed. They are the products of a cosmic construction project in which gravity builds bigger galaxies out of smaller constituents. Until now, astronomers have only been able to guess at how the universe as we know it came to be. Now, thanks to the Hubble, we can watch the process in action, touring from past to present. With Hubble as our looking glass, time is a landscape that stretches before our eyes, and a journey that is just beginning. In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. A great work of art is more than the sum of its parts. Although the artist works at the level of small detail, brushstroke by brushstroke, there is a larger idea at work, a design that expresses the artist's true intention. When the Hubble Space Telescope looks toward the heavens, it finds design on a grand scale, especially when it zooms in on the magnificent spiral galaxies that populate the universe around us. But rather than expressing the conscious will of the artist, this kind of design reveals the interplay of nature's fundamental laws. Our solar system is part of a galaxy called the Milky Way. It too is a spiral galaxy composed of hundreds of billions of individual stars, all moving separately around a common center of gravity. Yet through all of these separate motions, nature has achieved a single overarching design. Galaxies were not part of the universe of our ancestors. It was not until the 1840s that telescopes were powerful enough to reveal the tiny blobs and swirls scattered among the stars. At that time, even the word galaxy didn't exist. Astronomers believed everything they saw was part of the Milky Way, which appears to us as a great band of stars running across the night sky. So what were these strange spiral shapes that kept showing up in those first deepest glimpses of space? Many astronomers thought they were watching new solar systems coalescing among the stars. In the 1920s, American astronomer Edwin Hubble put an end to this idea forever. It was Hubble who proved that these beautiful spirals are not part of the Milky Way at all. Rather, they are entirely separate star systems, each just as vast as the Milky Way, but seen from a great distance. Hubble also recognized that many of the largest and brightest galaxies are not spirals at all. Instead, they are enormous and rather football-shaped concentrations of stars, which Hubble called elliptical galaxies. It has taken another generation of astronomers to understand why some galaxies are elliptical, while others display a striking spiral design. One clue has to do with the fact that spirals are much flatter than ellipticals. While elliptical galaxies are football-shaped, spirals are thin disks. This becomes obvious when a spiral galaxy is viewed edge-on rather than face-on. By analyzing the light from spiral galaxies, astronomers have found that they are disc-shaped because they are spinning rapidly. It's the force of their own rotation that causes them to flatten out, like pizza dough spinning in the air. But this fact also complicates our understanding of the spiral arms. Since the arms are not rigid objects, but made of billions of individual stars, it's hard to see how those stars can possibly turn together around the galaxy's center to maintain their spiral arrangement. Gravity dictates that just the opposite should occur. In our solar system, the planets that are nearest to the center orbit most quickly. In a spiral galaxy, the stars that are nearest to the galaxy's center should also be orbiting with the greatest speed. But if this is so, then a spiral pattern like this would wrap around itself after just a few turns and become stretched out beyond recognition. Some other explanation is needed to account for why spiral arms persist. Hubble images like this one appear to confirm the theory that in some galaxies, spiral arms move through the stars like giant waves. For example, the stars in this galaxy are all orbiting the galaxy's center, each at its own pace. But as they orbit, they are also passing in and out of the galaxy's spiral arms. Meanwhile, the arms are moving too, not as solid structures, but as shifting concentrations of matter that sweep around the galaxy like waves rolling across the ocean. With its unprecedented ability to resolve fine detail, the Hubble Space Telescope has become the premier instrument for showing us how spiral arms are formed and maintained. Astronomers are still trying to understand why spirals can look so different from one another. The Hubble has examined many of the nearest spiral galaxies, and they display as much variety as faces hanging in a portrait gallery. In some cases, the arms of a spiral galaxy can appear numerous and feathery, like the vortex of a cosmic hurricane wheeling through intergalactic space. In other cases, the spiral pattern is more distinct, with just a few large arms winding outward from the galaxy's core to its outskirts. A span so great, light would take tens of thousands of years to cross it. Appropriately, this kind of galaxy is called a grand design spiral, and it makes a stunning subject for Hubble's perceptive gaze. Still other spiral galaxies have long straight bars running across their centers, with spiral arms sprouting dramatically from opposite ends of the bar. From an artistic perspective, all these different kinds of spirals can be thought of as variations on a theme. It's clear that gravity and rotation dictate the general plan, but how that plan unfolds depends on the specific conditions particular to each galaxy. One important factor may be whether the galaxy is isolated in space or has another galaxy nearby. Without question, the most striking example of why this matters is the Whirlpool Galaxy. This is an awesome grand design spiral, featuring two bright arms beautifully coiled around each other. But it's not just the graceful arms of the whirlpool that give this galaxy its unmistakable appearance. Right beside it is a smaller galaxy that appears to be a companion. In this, the best image ever taken of the whirlpool, Hubble shows that the impression of a bridge between the galaxies is an illusion. The smaller galaxy is farther away, well behind the overlapping spiral arm. Nevertheless, the smaller companion is having a profound effect on the whirlpool. The pull of its gravity on the dust and gas of the larger galaxy is the likely stimulus that led to the formation of these remarkable spiral arms. Through Hubble's powerful optics, the arms can be seen as the crests of great waves of star formation. In sequence, we see long lines of dark dust, the raw material for a new generation of stars. They are followed by bright pink clouds, where newborn stars are already making the surrounding gas glow. Finally, we see clusters of bright blue stars that were produced earlier as the wave of star formation swept through. Somewhere among all of these stars and dust and gas, it's certain that solar systems are forming too, perhaps with planets capable of sustaining life. In the grand design of the Whirlpool Galaxy, we may, in fact, be witnessing the birth of a future galactic civilization. As inhabitants of the Milky Way, a spiral galaxy not so different from this one, we can easily infer that our own destiny was launched in the same way, on the crest of a spiral arm billions of years ago when our solar system formed. This is ultimately what is most profound about the elegant designs of spiral galaxies. They're not simply beautiful to look at, they are the shape of renewal and life in the universe. Formed by gravity and rotation, spiral galaxies require no higher intelligence to exist, but in their existence, they make possible the emergence of creatures such as ourselves that can build telescopes and gaze at the galaxies in wonder. What is the universe made of? To the eye, and to telescopes sensitive to the visible wavelengths of light, the answer is clear. The universe is made of stars, and the enormous congregations of stars we call galaxies. Look in any direction, and you will see them. Distant islands of light floating in an empty void. But this picture is far from complete. Today, astronomers realize that space itself is like a canvas upon which the stars and galaxies are set. And there is much more to this cosmic canvas than meets the eye. Now, thanks to the Hubble Space Telescope, in combination with other observatories, astronomers have confirmed that the canvas of space is being stretched in all directions. Even where it appears most empty, our universe is in the midst of a tug of war between the unseen influences of dark matter and dark energy. Using Hubble, these influences can be measured, but not directly. The word dark matter conjures up the vision of black clouds adrift among the stars. But dramatic images like this are simply showing the presence of ordinary dust, which absorbs starlight. Real dark matter neither absorbs nor emits light. It's not really dark at all, but utterly transparent. Its existence was not suspected until astronomers studying distant clusters of galaxies realized there was not enough matter in these galaxies for their mutual gravity to hold them together as a group. Somehow, there had to be more matter than was visible in the galaxies themselves. Then, studies of spiral galaxies like this one revealed there was something peculiar about the way these galaxies rotate. The stars at the edge of the galaxy should orbit much more slowly than stars near the center, but they do not. At least not as slowly as they should. The way to explain these unexpected motions, astronomers realized, was to imagine that each galaxy is embedded within a much larger but entirely invisible concentration of dark matter. In fact, astronomers now estimate that for every galaxy we can see, there is 5 times as much dark matter that we cannot. With the help of Hubble's keen eye, the fingerprint of dark matter can be found everywhere. Here, a dense cluster of galaxies exerts enough gravitational pull to bend light and distort the appearance of galaxies that lie further in the background. This effect, known as a gravitational lens, can be used to precisely measure the quantity of dark matter that surrounds the cluster. On a larger scale, astronomers have now used Hubble to gaze into relatively empty patches of space where background galaxies are distorted only slightly. Yet even such slight distortions can provide enough information to create a map in 3 dimensions that shows the distribution of dark matter that lies between us and these distant galaxies. This unusual image shows what may be the strongest evidence yet for dark matter. It depicts Hubble's view of 2 clusters of galaxies in the act of colliding. Both clusters contain hydrogen gas, which is energized enough to give off X-rays. The location of the gas is color-coded pink. Meanwhile, the blue color shows where the dark matter in this collision is located, based on the distortion of background galaxies. The simple fact that the blue has separated from the pink means that 2 great clouds of dark matter have passed through each other as easily as ghosts, while the gas clouds have collided, compressed, and heated up. Clearly, dark matter must be different from ordinary matter with very different properties. Hubble's detective work has finally glimpsed the trace of something human eyes were never designed to see. The combined gravity of matter plus all the dark matter in the universe should noticeably affect how the universe evolves. The universe has been expanding ever since the Big Bang, but over time, gravity should be slowing down the expansion. After its launch, one of Hubble's first big tasks was measuring the expansion of the entire universe. This may seem like an impossible feat, but Hubble did it by carefully searching nearby galaxies like this one for a special type of variable star. Stars of this type pulsate with a regular cycle, like a heartbeat. The rate of the pulse is related to the star's energy output, and therefore to its overall brightness. Simply by timing a star's pulsations, Hubble can tell us how far away the star is. This is exciting news. Hubble is the only telescope that can resolve pulsating stars in other galaxies well beyond our home galaxy, the Milky Way. And though the stars only take up a few pixels of each image, Hubble's views are good enough to record and time their pulsations. Once the measurements were made, Hubble could finally tell us how far away these galaxies are. And when combined with other observations, they provided the most accurate estimates yet for the expansion rate and the age of our universe.
The results were unexpected. According to Hubble, the universe was less than 12 billion years old. Yet, independent measurements of the oldest stars in our galaxy, also made by Hubble, showed they were older. And that posed a problem. How could the universe possibly be younger than the stars it contains?
To answer the question, astronomers again turned to Hubble, this time using the Space Telescope to look for a specific type of supernova or exploding star. Like a pulsating star,
A supernova can be used to measure the distance to a galaxy. But it's bright enough to be seen from much farther away. Because the light from these galaxies takes longer to reach us, Hubble's measurements reveal how the expansion of the universe has changed over time. And after looking at many more of these faraway explosions, astronomers have come up with an astounding result. Because of the combined gravity of all the matter and dark matter it contains, the expansion of the universe should be slowing down. Instead, it's actually speeding up. It was this revolutionary finding that allowed astronomers to realize something else is at work in the cosmos, a dark energy that appears to be woven into the very fabric of space itself. Astronomers are still trying to understand exactly what dark energy is and what will happen in the far future as the universe continues to expand faster and faster. For now, we can say that when Hubble stares off into space, it's showing us the battleground of a titanic struggle between invisible forms of matter and energy. The art of Hubble plays out on a restless canvas. A canvas that dictates not only everything we see, but our own destiny in the universe. In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. Like the vanishing point in a perspective drawing, the core of a neighboring galaxy attracts our gaze and makes us feel as though we're staring down a deep well with a bright, shining center. But this illusion conceals an even deeper truth. Investigations by the Hubble Space Telescope suggest that at the center of most galaxies, there lies a giant black hole. A real-life vanishing point into which matter and light can disappear, never to be seen again. A black hole is a bizarre place where weird physics reigns supreme. But the force that gives rise to a black hole is the same force that governs just about everything we see in the universe, from planets to stars to entire galaxies. It's gravity. Located on the outskirts of our own galaxy, the Milky Way, this is a globular star cluster. Although it's much smaller than a galaxy, it's still mind-bogglingly huge, containing hundreds of thousands of individual stars. Held together by their mutual gravity, these stars have arranged themselves into a perfectly spherical cloud. On a smaller scale, gravity is the force that brings atoms together to make stars and planets. These objects look round because a sphere is the smallest volume into which a given amount of matter can be packed. And the more matter available, the stronger the force of gravity that pulls it all together. Among the nearest stars to Earth is Sirius, the brightest star in the night sky. It's sometimes called the Dog Star because it belongs to the constellation Canis Major, the faithful canine companion to Orion the Hunter. Looking at Sirius up close, the Hubble shows us that the Dog Star has a companion of its own. Known as Sirius B, this tiny star is an example of what gravity can do under more extreme circumstances. Astonishingly, Sirius B contains as much mass as our Sun, yet it is no larger than Earth. This has happened because Sirius B is a dead star. When its energy ran out, gravity took over and compressed its atoms into an ultra-dense state known as a white dwarf. Elsewhere in the universe, gravity makes possible even more extreme states of matter. For example, the violent supernova explosions that mark the deaths of the brightest stars also unleash enough energy to create neutron stars. In a neutron star, atoms are crushed together to form an object 10 trillion times as dense as solid lead. A typical neutron star contains nearly twice the mass of our Sun, yet it is no larger than a small city. Because they are so small, neutron stars are very faint. Yet with its eagle eye, Hubble can spot a lone neutron star adrift in interstellar space. Since a supernova can produce a neutron star, it makes sense to search for one where a supernova has occurred in the recent past. In 1987, a supernova lit up the skies of the southern hemisphere. When Hubble was launched a few years later, astronomers were eager to observe the aftermath. What they found, nestled in this rose-colored cloud of interstellar gas, was a strange and remarkable sight. At the very center of this image is the exploding fireball of the supernova. But it's encircled by a bright ring of material that was released before the star exploded. Over a 10-year period, Hubble has watched this ring brighten as it's heated by the expanding shock wave from the supernova. In a universe where change is typically measured over millions of years, Hubble has given astronomers a rare gift: front-row seats to a stellar explosion in progress. And like a cosmic Christmas wreath, the ring is now aglow with supernova energy.
It's here in the center that astronomers have been looking for the neutron star, but so far it hasn't appeared. Perhaps the neutron star is still concealed in enveloping layers of dust. Or perhaps the size and gravity of the star that went supernova was enough to create something else: a black hole.
When matter can no longer resist the relentless pull of gravity, it forms a black hole. a region of space where the gravitational field is so strong, not even light can escape. To encounter such an object adrift in space would be to see nothing at all, except the light of background stars bent by gravity around the edges of the black hole's event horizon. Even more intriguing is evidence that at the center of our galaxy there lurks a black hole of gigantic proportions. The giant black hole is not visible to the Hubble because it lies concealed behind the dark dust that screens the central region of the Milky Way from our direct line of sight. So to hunt for giant black holes, Hubble must turn to other nearby galaxies where it can peer directly into their central regions. This is the Andromeda Galaxy, a vast, swirling metropolis of stars that is twice the size of the Milky Way. A decade ago, astronomers were puzzled by a strange bluish light that seemed to come from the very center of Andromeda. With Hubble's help, they have now solved the mystery of the blue light. It is produced by hundreds of bright blue stars, wheeling around Andromeda's center at speeds approaching 20 million miles or 32 million kilometers per hour. Only the powerful attraction of a giant black hole could force stars to race so quickly. Than Andromeda, in the galaxy Centaurus A, Hubble finds more direct evidence for the existence of giant black holes. This galaxy is surrounded by a ring of dark dust, dust that was acquired from a smaller galaxy that merged with Centaurus A long ago. A classic case of galactic cannibalism. Looking deeper into the partly obscured heart of Centaurus A, Hubble unveils what astronomers once could only imagine: a glowing core where gas from the cannibalized galaxy is feeding a giant black hole. Unlike the black hole at the center of our Milky Way, this object is active and obvious, and when Hubble switches to an infrared view, it directly sights the vast disk of material swirling around the black hole. As Hubble turns its roving eye elsewhere, increasingly it finds that giant black holes are a common feature at the centers of many large galaxies, including galaxies like our own. And though these black holes ultimately destroy what they devour, Hubble's exploration of them has left us with a surprising revelation. These mysterious and terrifying monsters, the universe's vanishing points, may have played a critical role in the formation of the galaxies that surround them. If so, they are key components of Hubble's universe, a universe that not only offers great beauty, but that also populates itself with curious creatures who can ponder the remarkable circumstances of their own existence. Spreading before us like a giant canvas, the universe revealed by the artful eye of the Hubble Space Telescope is a universe of opposites. At one extreme, the stars burn white hot, sometimes illuminating colorful clouds of interstellar gas with their high-temperature glow. At the other extreme, the darkness between the stars is a frigid vacuum, a space so empty we would need to scour 1 million cubic miles or 4 million cubic kilometers to find enough atoms to make a single drop of water. At first glance, these extremes of light and dark do not seem to offer much hope for life in the universe. The stars are too hot, and space is too cold for life to exist. But fortunately for us, there is more to this picture than meets the eye. Planets that orbit around the stars offer the promise of a middle ground between the universe's two extremes, a habitable zone where life can gain a foothold. Our own solar system is the starting point in our understanding of how and where life can emerge in the universe. Here we find a diverse family of planets, ranging from small and rocky to large and gaseous. We also find that on at least one of those planets, Earth, conditions are just right for life to flourish in abundance. The small fraction of the sun's energy that splashes onto our world is just the right amount for water to exist as a liquid. And that same energy sustains millions of species of plants, animals, and microbes. Elsewhere across the galaxy, we find the building blocks for planets and for life scattered among the stars.
It's natural to wonder how much life could there be in the universe, and where should we look for the planets that can support it? These are not just fundamental questions of science, but questions that lie at the heart of our own sense of what it means to be alive in a vast and mysterious universe.
Only recently have astronomers had the tools to begin the search for life in the universe. And among the most powerful tools of all is the Hubble Space Telescope. Like other telescopes, Hubble faces a serious challenge. To search for life, astronomers must search for planets around other stars. But even for Hubble, those planets are too faint to see directly. Instead, Hubble has found clues that reveal how and where planets form in our Milky Way galaxy. The birthplaces of new planets are the same places where we can see stars in the making. They are towering clouds of dust and gas, where material is gradually pulled together by the force of gravity. Cloaked behind a veil of dust, hydrogen and other atoms begin gathering inside the clouds. As they grow more concentrated, they pull in more material until the entire cloud coalesces into a cluster of infant stars. Powered by nuclear energy, young stars can shine with a light so intense it pushes aside the cocoons where they were born. And as the dusty veils are lifted, Hubble gives us a front row seat to the creation of new worlds. The Orion Nebula is the nearest star-forming region in our galaxy, and so it gives us the best chance of seeing how new stars give rise to new planets. In its central region, a quartet of stars shines with the light of 10,000 suns. Together, these bright stars have formed a hollow cavity within the Orion Nebula, allowing astronomers to peer inside. What they have found is a large population of freshly minted stars, and also something more. Many of the stars at the center of the nebula are surrounded by leftover material from star formation. This includes dust, which is easily spotted because it absorbs light and appears dark against the background glow of energized gas. In example after example, we find that rotation and gravity have acted together to shape the dusty material into flat disks that swirl around their stars. Over a period of tens of millions of years, the material within these disks will eventually start clumping together to form planets. Astronomers have long suspected that solar systems form this way, but only with Hubble have they been able to capture the process in action. To gain further insight into the story of planet formation, astronomers have focused their attention closer to home, using Hubble's resolving power to search for disks around nearby stars. In this image, the light of a star similar to our own sun was artificially blocked by Hubble's camera. This allows the Space Telescope to discern a faint reddish glow around the star, a glow that is caused by a surrounding disk of dust. The dust particles that are responsible for the glow are tiny, like particles of smoke. But buried within the disk, astronomers suspect there are larger clumps, the building blocks from which planets can form. Here, Hubble discovers what at first glance appears to be a giant eye in space. This is Fomalhaut, a bright star located in the same part of the Milky Way galaxy as our own solar system. Once again, the star's light is artificially blocked to reveal the faint light of surrounding dust. But here the dust appears as a narrow ring. The ring is a strong clue that a planet has formed around Fomalhaut. As this illustration shows, the planet likely orbits just inside the ring, where it's in the process of sweeping up dusty material. Meanwhile, Beta Pictoris, another nearby star, offers a different angle on planet formation. Here, a dusty disk is seen almost exactly edge-on. This is Hubble's sharpest view of Beta Pictoris, and it reveals a surprise. The star is surrounded by two disks rather than one. A likely explanation for this is that the gravity of a newly formed planet is disturbing some of the dust that orbits the star, creating a slanted second disk. Hubble's observations of disks around other stars have allowed astronomers to see what planet formation looks like from a distance. It's also been like a time machine that lets us see what the origins of our own solar system may have looked like 4.5 billion years ago. In a different way, Hubble is also helping to find planets that formed in the past. To do this, it has stared into the densest part of our Milky Way galaxy, toward a dust-free region known as the Sagittarius window. The result is this dazzling view that contains some 200,000 stars. The odds are that in a sample this large, many stars will have planets. And a few of those planets may pass in front of the stars they orbit just when Hubble is watching. Sure enough, when Hubble monitored this portion of the sky for 7 consecutive days, it spotted several stars temporarily growing dimmer by a small amount. In one case, a star dimmed every 10 hours with clock-like precision. Follow-up observations have confirmed this star is circled by a planet with roughly the same size and characteristics as Jupiter. Such a planet is not the kind of world where life as we know it would find a comfortable home. Nevertheless, this groundbreaking work by Hubble is blazing a trail for future space telescopes, which will someday be sensitive enough to detect Earth-like planets as they pass in front of their stars. By opening the door to the discovery of new worlds, Hubble is bringing us closer to answering one of the most important questions of human existence. Are we alone? Our presence means that we are not just passive spectators of the universe. As Hubble has now revealed, our planet, like so many others, has sprung from the raw materials of the universe, and it's led to our emergence as an exploring species. This realization gives new meaning to the striking vistas we see spreading before us as Hubble probes the deepest corners of the cosmos. What makes the universe so beautiful is not simply the matter and light that gives rise to such extraordinary variety and detail. It is the fact that we are here to see it, the living witnesses that makes this a living universe, a conscious universe, a universe that can see through the eyes and minds of those that live within it.